this video, we will find for the mean and the sum of the terms of an arithmetic sequence. To understand the concept of arithmetic mean, let us use the sequence 5, 10, and 15. So we have to remember that this sequence is a finite sequence. 5 is A1, which is the first term. 10 is A2, which is the second term. 15 is A3, which is the third term. A1 and A3 are considered as extremes of the sequence. The term between the first and the last term is called mean. In this finite sequence, 10 is our arithmetic mean. For this problem, we have to find for the arithmetic mean between 15 and 17. So we have to remember that 15 is our A1 and A3 is 17. A2 is equal to 15 plus 17 divided by 2. The sum of 15 and 17 will be divided by 2 since we are looking for the arithmetic mean. 15 plus 17 is equal to 32 divided by 2 is equal to 16. So the arithmetic mean between 15 and 17 is 16. This is another problem involving arithmetic means. We have to insert for arithmetic means between 9 and 29. 9 is the first term, the second, the third, the fourth, and the fifth terms are unknown, while 29 is our sixth term. A1 is equal to 9 and A6 is equal to 29. We find the value of D. The first step in finding for the arithmetic means is to find for the value of D. We have to use the equation AN is equal to A1 plus N minus 1 times D. Next is substitution. AN is equal to A6. A1 is 9 plus N is 6. So 6 minus 1 times D. The value of A6 is 29 is equal to 9 plus 6 minus 1 is 5 times the common difference or D. By subtraction property of equality, we can simplify this by 20 is equal to 5D. It is 20 is equal to 5D since in subtraction property of equality, we have to remove 9 here by subtracting 9. So 9 minus 9 is equal to 0. And when you do at this side, you should also do at the other side. So 29 minus 9 is equal to 20. So 5D, to remove the 5 here, we should divide it by 5. So 5 divided by 5 is equal to 1. And 20 divided by 5 is equal to 4. So the common difference is equal to 4. Completing now our arithmetic means, it will now be A2 is equal to 9 plus 4 is equal to 13. So our A2 here is 13. And continue adding 4. 13 plus 4 is equal to 17. That is now our A3. 17 plus 4 is equal to 21. That is now our A4. And 21 plus 4 is equal to 25. That is now the A5. The four arithmetic means between 9 and 29 are 13, 17, 21, and 25. Series. The sum of all the terms of a sequence is called a series. For example, 1, 3, 5, 7, 9 is a sequence. And we have to remember that this is an infinite sequence because this is denoted by this symbol. While 1 plus 3 plus 5 plus 7 plus 9 is a series. When the difference between each term in a series is constant, as in this example, the series is called an arithmetic series or arithmetic progression. So this is actually an arithmetic series because there is a common difference in the sequence. So the common difference is 2. The sum of the first n terms of a sequence called a partial sum is denoted by Sn. So for the series 1 plus 3 plus 5 plus 7 plus 9, that will be S5 is equal to 1 plus 3 plus 5 plus 7 plus 9. So when we add these numbers, that will be 25. When n is large, a more systematic approach for calculating the sum of a given number of terms is required. It is said that when the famous mathematician Carl Friedrich Gauss was a young boy at school, his teacher asked the class to add together every whole number from 1 to 100. The teacher expected this activity to keep the class occupied for some time, and so he was amazed when Gauss put up his hand and gave the answer 5050 almost immediately. Now, what is actually the secret of Carl Friedrich Gauss? So Gauss worked the answer out by noticing that you can quickly add together consecutive numbers by writing the numbers once in order and once in reverse order and adding them together. So we have to highlight writing the numbers once in order and once in reverse. So to add the numbers from 1 to 100, the first S, which is the numbers in order, so that is from 1 to 100. And the second S is from 100 going to 1. So that is actually the reverse of the first S. So adding now our 2s, s plus s is equal to 2s. And 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. 5 plus 96 is 101. And that is a sequence or a series. And until you go at the last terms, that is 100 plus 1, that is still 101. So 2s is equal to 100 times 101. This 100 is referred, or it's because of the number of terms. So that is from numbers from 1 to 100. So 100 times 101 is equal to 10,100. So removing now the value of 2 here, divided by 2, that is 1. And you will also divide this by 2. So 10,100 divided by 2 is 5,050. Now we have to derive the formula for an arithmetic series. The terms of an arithmetic sequence can be written as A1, then A1 plus D, A1 plus 2D, and AN minus 2D, AN minus D, and AN. So we write the arithmetic series as, okay, so in this is our equation 1. And if we reverse the order of addition, we have this equation 2. So if we're going to add now the equation 1 and equation 2, this will become 2Sn is equal to A1 plus AN and A1 plus D plus AN minus D, cancel D, that will lead us to A1 plus AN. And in here, 2D minus 2D, that is 0. So A1 plus AN. So this is almost a similar concept with how Gauss arrived at his answer. So it will now lead us to this equation. Since there are as many binomials being added as n, then we write 2Sn is equal to n times the sum of A1 plus AN. Solving for Sn, we have, if AN is given, we have our formula 1. So you will just divide 2 here. So it will now lead us to n over 2 times the sum of A1 plus AN, where A1 is the first term, AN is the nth term, last term, and n is the number of terms. And expanding AN from formula 1, if AN is not given, so we have our formula 2. So from our equation in finding the nth term of a sequence, we will just use that formula to expand this formula. So we have now Sn is equal to n over 2 times 2A1 plus n minus 1 times t, which is the common difference. AN is the first term, D is the common difference, and n is the number of terms. So we have this example number 1. Find the sum of the first 30 natural numbers. So we have 1, 2, 3, 4 until 30. Given we have a1 is equal to 1 and an is equal to 30. That is our last term. And n is equal to 30. 30 because there are 30 natural numbers. So we will just substitute to Sn is equal to n over 2 times the sum of a1 plus a1. So that will now be 30 over 2 times an is 1 plus 30, that is 31. And the answer now in here is 465. 30 times 31 divided by 2, which is 465. Example number 2. Find the sum of the first 12 terms of the arithmetic sequence 50, 47, 44, 41, and 38. So given a1 is equal to 50, d is equal to negative 3, and n is equal to 12. D is negative 3 because 47 minus 50 is negative 3. 44 minus 47 is negative 3. So we will use the equation number 2. Substitute to Sn is equal to n over 2 times 2a1 plus n minus 1 times d. So we will just substitute. So we will now have 12 divided by 2 and copy 2, and a1 is 50 plus n is 12 because there are 12 terms in the problem, minus 1 times the common difference. So it will now lead us into 6 times 100 minus 33. And to have the final answer in this, 100 divided minus 33 times 6, that is 402. So this is now your turn to solve the following problems. We have two parts of solving problem. We have the arithmetic mean and the arithmetic series. For number 1, we have what is the arithmetic mean between 85 and 95. Number 2, what is the arithmetic mean between negative 12 and 4. Number 3, insert 3 arithmetic means between 17 and 1. And for letter B in arithmetic series, you'll find for the sum of the first 6 term of an arithmetic sequence 1, 5, 9, 13, and 17. For number 2, you will find the sum of the first 21st terms of the arithmetic sequence 3, 10, and 17. And find the sum of all multiples of 3 between 5 and 64. For number 1, we have 90. For number 2, we have negative 4. Number 3, 13, 9, and 5. For letter B, number 1 is 66. Number 2 is 1,533. And for number 3 is 640.